Welcome to video 5B. In this video, we are going to continue working with our volumes and surface areas of three-dimensional figures. In particular, we're going to talk about pyramids and cones. We are going to do volume first, and then we'll move into surface area. So first of all, let's go revisit our pyramid shape. So when we have the formula, we know what to put in. Let's just make how about a hexagonal pyramid. Remember, we named them with their base shape. Remember, pyramids have one base and faces that are triangles. So I'm going to connect here, here. Missed it a little bit on that one. Here, here, here. So there's my hexagonal pyramid. Remember, we call this bottom the base, and capital B in all of our formulas stands for the area of the base. Capital P stands for the perimeter of this base. Our base is always going to be a regular, for the most part, polygon, which means the sides and the angles are congruent. And for a pyramid, our faces are triangles. So there's my base. I'm going to redraw these so you can see them. And for our volume, remember for the prism, we did capital B, area of the base, and we pulled it up with the height. Well, a pyramid takes up 1/3 of the space of a prism. So we have a 1/3 multiplier out front when we work with the pyramid. So what I want to do here is draw the height in. I'm going to try to get a different color here. Maybe yellow will work. The height is always drawn inside here. I'll draw it like that, perpendicular to the center of that. So go ahead and point at this and call it H. And remember, capital B stands for the area of the base. So if we can find the areas, and if they hand us the height, we just plug it in like a map. Similarly, for the cone, cones and pyramids are pretty similar. The only difference is the cone has this circular base. For the cone, our volume is equal to basically the same thing, 1/3 area of the base, but in this case the base is a circle. And the area of a circle is pi r squared. And then we still pull it up with its height. Now without the 1/3 in front of it, this is the volume of a cylinder. So what happens is, when you have the cylinder, and if I were to put a cone inside of it, what that means is it takes up 1/3 of the space in there. So we have that 1/3 multiplier. But again, if I can just be handed the radius or the diameter and I cut it in half, and if they hand me the height right here, then I just plug them in. So let's go practice that. Finding the volume. What is this shape? This is a pyramid. The area of a pyramid, you should always write the formula down. Go find it if you don't remember it, is 1/3, and it's right above there, so you shouldn't have any difficulty finding it. Capital B, H. What you might want to do is go find capital B kind of off to the side, but capital B is the area of this base right here. This base is a rectangle. The area of a rectangle is length times width. So capital B is going to equal 2 times 5, which is 10. The height of this pyramid was handed to me. It's 5. So put an H right there. So now when I go plug these in, the volume of my pyramid is 1/3 capital B H. Now 1/3 of 10 is 10/3, or 3 1/3 or whatever, but usually the best way to leave these to keep them exact is, since 3 doesn't go into 10 or 5, I'm just going to leave it as 50/3, and that's perfectly legal. And this is volume, so we label it inches cubed or cubic inches. There we go. Next one up, I've got a cone. So I go grab my formula for volume of a cone. It is equal to 1/3 pi r squared h. So let's go pull off what we need. We need to find the radius. It was handed to me, so I'm going to replace that with a 2. I need to find the height. It was handed to me, so I'm going to replace that with a 7. So I'm going to do 1/3 pi r, which is 2, height, which is 7. I'm going to leave this one in what we call in terms of pi, because that's what happens a lot when you take standardized tests, and in particular the ACT. So I'm going to leave this in terms of pi. What that means is pi is irrational. It goes on forever and it never repeats. The minute I round it, I'm off a little bit. So a lot of times you're told to leave the answer exact, or sometimes they'll say in terms of pi. That's right, AKA. What that means is you go do all the non-pi parts, and we're not going to use a calculator. We've got 2 squared, which is 4. 4 times 7 is 28, and there's a 3 on the bottom. So we write 28/3 is the non-pi part of this, and it doesn't reduce, so I just leave it. I don't go make it a decimal. I mean, you could, but I'm asking you not to on this one. And the pi is on top. It's really pi over 1, not 1 over pi. You're multiplying by pi, not dividing. So we put the pi up here on top of the fraction, and we'd call this miles cubed. Boy, that's a big cone. Holy smoke. A 7-mile long cone. That's ridiculous. I think that might be a typo. Maybe it's supposed to be meters or something. I've got the world's biggest cone. All right, let's go to the next section here. On the next page, we are going to be working with surface area of pyramids and cones. So let me grab this, move it on up. And now instead of filling these up, we are going to cover them, because that's what surface area does. So this is a little bit more complicated, but again, let's go draw ourselves a cone. Let's draw a hexagonal one again. I mean, not a cone, a pyramid. So let's go draw our pyramid. I'm going to put a hexagonal one here. 1, 2, 3, 4, 5, 6. And let's make that look like it's a little bit more regular. All right. Remember, regular means all. Still struggling. I'm sorry, I'm not the best drawer. All right, there we go. I'm going to loft a dot up here. I'm going to connect that dot to all of these vertices here. Could kind of do it dotted in the back if I wanted to. But there is my hexagonal pyramid. It's pretty decent. And again, we've got the area of the base, we've got side lengths, etc. I'm just going to give you the formula right now for surface area. The surface area is capital B. Again, that stands for area of the base. So whatever's on the bottom here, you're going to have to find the area of it. I like to do that off to the side when I do them. And then we do plus 1/2 P. Remember, that stands for perimeter of the base. So when I'm doing P, I'm going to do this, plus this, plus this, plus this, plus this, plus this, but they're all going to be the same. So I could really, on that one, just do 6 times a side length, but I have to travel around that base. And then I've got a new variable that I have to explain here, right here, L. Go ahead and point right here. It's called the slant height. And what it is it's the height of one of those triangular faces. So what I'm going to do here is I'm going to blacken and delineate one triangular face, that one. And what L is the height of that. And you'll be given it. So no worries trying to find it. We'll hand it to you, but that's L. And where the 1/2 PL comes from is really every one of those triangular faces is 1/2 base times height. And when I travel around here and do that for all of those triangular faces, that's where the perimeter comes from. So really it's just this right here, which we call the lateral area. It's really just adding up all those triangles that are on the side. All right, so for our cone, we've got this going. And our surface area is going to equal, again, the area of the base. The difference here, though, is that the base is always a circle. So we always have pi r squared, and that'll cover the bottom of this. Whatever that is, that'll cover the bottom of it. And then to get the lateral area, or the sides, we do pi r, and then we have that new variable L in there. And L on a cone is this right here. You can go point at it. Otherwise, the formulas are really just plug and chug. So formulas are like a map. You just write it down and you follow the directions. So this is surface area of a cone. So I go grab my formula for surface area of a cone and I write it down. Surface area of a cone is pi r squared plus pi r L. And I go plug in the r and I plug in the L. L R. So I do pi times 13 squared plus pi times 13 times 30. And I'm going to let you go ahead and take care of that on your calculator. I will allow you to round this one to the nearest tenth, but I'd also like it to be exact. And let's see if you remember what I mean by that, because I'm going to put those two boxes down in your notes, and I'm going to check those when you come up to get my signature. So when I say in terms of pi, let's do the decimal right here. Then you can just go to your calculator and you just hit your pi button, or if you don't have one, go ahead and use 3.14. And you're just going to go pi times 13 squared plus pi times 13 times 30, enter. And you're going to round that to the tenths. When I say leave in terms of pi, I want the pi in your answer. So you're only going to do this. You're only going to do this. You're going to have a pair of like terms, similar to this, 3x plus 8x equals 11x. The difference is you're going to have pi's here, because of here and here. So I want to make sure you know how to do that. So I'm not going to complete that part of it. Next page. Next up, I have a pyramid, and I am going to find its surface area. So I'm going to write the formula down, and I'm going to follow it like a map. Pyramid is cover the bottom plus cover all these triangles. And to do the triangles, we do 1/2 base times height. The height in this situation we call L for slant height. The reason they do that, by the way, is because the height of the pyramid itself is actually inside here. It's how tall it is. So we need another variable for the height of each triangle, and we use L for that. And when I do all of the triangles, I really will have traveled around here, so we do P. All right, let's go get the area of the base. I'm going to do that off to the side over here. The area of my base is, I go down here, it is a square. I do length times width, and I get 400. And the perimeter of the base, I like to get all my key players on here, would be to travel around here and go 20 plus 20 plus 20 plus 20, or easier yet, 4 20s, or 80. So now this and this are ready to be dumped into my formula. Surface area is capital B, 400, plus 1/2 P, 80, times the slant height, 26. And then you'll go to your calculator and you'll calculate that out. Shouldn't be any rounding. It should be a nice answer. And then here's the net for it, by the way. This is what would happen if you cut each of these on the seams and all those triangles fell flat on the floor. And that's really what you're finding is the surface area of this. The capital B gives you this part. The 1/2 PL gives you all of these. And then when you add them all up, you end up covering the entire surface. And again, had this been labeled in inches, because this is surface area, my answer is going to be labeled in inches squared. So when you do your worksheets for these, what I would like to see you do is write the formula down. Whatever it asks you for, write that formula down, find what you need, and plug it into the formula. I'm going to, before you stop though, go back to our sheet that's got the grid on it. So we're keeping track of everything on here, so that you have a master sheet to use, a master map, if you'd like to call it that. Today, we did our pyramids and cones, so let's go throw that on there. Our pyramid, let's just go draw a square pyramid here. Ugh, terrible, terrible, terrible. Let me draw a better one. Slow down. Little better. Still not the best pyramid. Good enough though. Let's put our key parts on here. Go put this on. Remember, we call that L, right? And then if you want to shade in the bottom here and point at it and write capital B is the area of the base. And that'll change. I mean, it depends on what's sitting there on the bottom. So we have our surface area, which I just said. The surface area is equal to 1/3. See if you remember what it is. I'm sorry, I'm putting the volume one in there. Is capital B, I'm going to cover the bottom, plus 1/2 PL. Then I have the volume of my pyramid. Cover the bottom, pull it up with the height of the pyramid. So let's go put that on there. That's inside it. It's how tall it is. When you fill it up with water, it's how deep it is. You might want to point at that. It's hard if you don't have multiple colors, I know, but do your best. But then we do 1/3 multiplier out front. I'm just going to make sure I'm putting these in the right columns. I believe, yep, it goes surface area volume. I wasn't sure if it went volume surface area, and I didn't want to screw up there. So next up with our cone, let's go draw ourselves a picture. Let's go put our key players on there. We need the radius. And we need this side over here, which we call L for the slant height. And then, let's go back to purple. When we do our surface area, we cover the bottom, which is a circle. And then we cover the, if you were to kind of cut this and lay it flat, it kind of would make like this shape. And the area of that is 1/2. No, it's not. It's pi r L. And then we just stuff those in there, and it's nice and easy peasy mac and cheesy. The volume is, cover the bottom, pull it up with the height of the cone. So again, the L is the slant height. Height of the cone is inside of it, which we need for the volume because its depth will greatly affect the volume. So it's got an H there. If I leave it like that, that would give me the volume of the cylinder that has the same radius and the same height, but the cone takes up 1/3 of the cylinder. So there you go. Now you're ready to go work on your worksheet. Have a good one and good luck.